and welcome back for a new video. So today what I'm gonna show you is the Chinook database. Now, what is the Chinook database? To go ahead with my tutorial about .NET 6 and Entity Framework, I decided to use something a little bit more designed for real life, and trying to implement my own would actually be a huge amount of time for me. So I decided to use something that has been used many times, and it's called the Chinook database, which is an alternative, as you can read on the official GitHub page, which I will link in the video description below, to the Northwind database. The reason why this one has been created is because it's can be used for demos and to test ORM tools. And it supports all of those technologies. And essentially, what does it do? It has a digital media store. There are artists, albums, media tracks, invoices, and customers. In my implementation, I'm actually going to use something a little bit simpler, simply because we don't have to make a full store with invoices, customers, artists, track, albums, etc. I'm going to use a stripped down version, which I'm going to show you later. So, anyway, in Leorcha Chinook database is where you can find all of this. The tables I'm going to actually use for my examples are the album, artist, genre, media type, playlist track, and track. And then this one is the model, and the model which essentially follows a standard, a convention that is a little old. I've actually made a few changes. So let's go. I'm gonna go back to my VS Code, and in here I have my usual folder with the items we saw so far. I made a little bit of cleaning up. So in the entity folder I have removed everything. It's basically a fresh start. Inside the controllers there is nothing anymore. So everything we saw so far in the previous lessons is still valid. We're gonna use some of the things we learned to create those models. So let's start from here. We're gonna start looking at the basic types. I'm not gonna type anything. I already prepared the files with the contents. So first of all, we have a media type. A media type is going to represent, for example, if it's a DVD, a CD, a cassette, a digital download, MP3, and whatnot. So we have an ID and we have a name. Then we have a genre. A genre has an ID and has a name. Now, what could actually be done here is that instead of using a GUID of type ID, I could actually make the string the primary key of this table. However, to keep things simple, I decided not to do so. Then we have the track. The track, it's made by many items. You can have a look at the original Chinook database. It matches it almost one-to-one. So let's have a look at it. There is a primary key, there is the composer name, there is the name of the track, which is required and has a max length of 200. This is a very simple validation that we can add, but later on I'm actually planning to add more types of validation using Fluent validation. So if you're interested in these topics, please subscribe and leave the notification bell. This is the order. It's supposed to be the orders according to the author of the Chinook database. Then we have milliseconds, which is the duration, and then we go to the relationships. So the relationships, we have the album and the album ID, and we're gonna use this key to actually refer to the album table, which we are going to create. Same goes for media type. The media type is going to be referred as one-to-one. Okay, so it only has one media type. Then we have a genre and a genre ID, which they are linked in the same way. And finally, we have a collection of playlist tracks. Actually, I just realized here I made a small mistake. This one should be a virtual collection. I'm going to explain what a virtual keyword does in Entity Framework, and it's related to something called lazy loading. is essentially makes possible for Entity Framework to load these playlist tracks more easily and to query without actually having to overload the memory. It's a little bit like saying, okay, we have playlist tracks, but EF, please don't worry about it. We can ignore it. It's a little bit like a nullable field, so to speak. And here, because I don't want to initialize it to something empty, so I could actually do this, but then it will complain that this one could be possibly null and needs to be a non-null value. So because it needs to be a non-null value, I'm going to use an hash set of type playlist track. I have a playlist track, which is the composition of many things. It can be a playlist and a track, and they move side to side. This is essentially a joined table. Then we have a collection, a playlist, which is again has an ID, has a name, and has this collection of playlist tracks, and works exactly the same as you have seen in track. A track can belong essentially to many playlists, and a playlist can have many tracks. That is the meaning of these two relationships. And okay, so from here we're gonna move to the data layer. In the data layer, I have a database context. Inside the database context is exactly what we had before. Works the same way, but we defined 3 DB sets: tracks, playlist, and playlist tracks. What is the reason that we only implement those 3? So the reason is that if you look at track uses album, track uses media type, and track uses genre. So when EF is going to create tracks, it's also going to create this extra database column, because tracks is a central table in our schema. Then we have the playlist. The playlist implements playlist tracks. And finally, playlist tracks, it essentially glues everything together and is going to create this joined table for us. So moving along, as you know, DB context is the base class that we are actually using to create those models. Now there is this method here on model creating, which actually allows us to override the way in which the normal builder will work. So we can actually exclude this block in here, and Entity Framework will actually create the tables in our model just fine. However, we want to make some tweaks to the way in which the relationships are built. Now, for clarity, I moved this model builder apply configurations from assembly. It's a method that actually allows us to apply those models coming from the data context, which is defined in the data layer. Okay, so it says the data context, and then you give me the assembly, and it's gonna find those assembly which are defined inside this data context folder of the data context. We saw why we don't need those 3 items. We don't need to put all the tables, and we just need to put the tables that are central to our API. Now, in this model creating, we apply configurations from assembly. And essentially what it means that inside this data context is going to find all the entity type configuration configuration of the entity that are provided inside this context. So in here I have this models folder, and inside this model folder what I have the configurations of classes which are extending this interface for each one of those identities. So I'm gonna have an identity configuration for album, I have one for the artist, I have one for the genre, one for the media type, and so on. So let's have a look, starting from the album one. We have this first of all, I named this one as an internal class. The reason is that I don't want this to be outside of this model. Okay, so we don't need this to be exposed in any way outside of data layer. Data layer, all it has to know is the data context. Is going to use the model, and that's all it needs to know. So this one, it's another way to actually implement the relationships in our table. So let's have a look at what each line does in here. Then we'll go, as we go on, we'll move a bit more quickly. So the first bit is entity to table album. It says instructs Entity Framework to create a table in the database named album. The second is gonna say that the ID is of type album, and the name ID is we're gonna give a name of primary key album as our convention. Then we say that the column name is gonna be album ID, and then the title is gonna be title lowercase. The artist ID points to artist ID, and each album points to one artist. Now move to the artist configuration. Everything is the same. We're gonna make an artist table. The ID as name primary key artist and artist ID, and the name as a name of lowercase name. Genre is gonna be genre, primary key genre ID. I think you got the gist. So let's move to something a little bit more fancy. Let's have a look at the playlist configuration. So in here is exactly what we saw so far. In here, what is different is that the playlist configuration file, which implements the table playlist, has many tracks, and each one of the tracks has one playlist. So this one is saying, my playlist has many tracks, and each track in the playlist has a playlist. The playlist track configuration has two of those items. The first one is that the playlist track has a track and has many playlist tracks, while the playlist ID has one playlist and many tracks. So these one are are essentially saying one is for the track, one is for the playlist, and they use the playlist ID and the track ID as column. The last one is the track configuration file, and that's the most complicated among all of those because it has many column names. So in the first section, all I'm doing, I'm following the convention of putting every name in a lowercase, and the names are with an underscore in between. So unit price, genre ID, album ID, as you saw so far. However, here we have the name of those properties. The genre, there is only one genre, there is only one album per track, and then there is one media type and as many tracks. So it means that one track can actually belong to many playlists, and in each playlist we only have one track. So we are saying that the track cannot be repeated in the same playlist. Okay, so here I've generated a couple of playlists. Here generated the migrations. So as you can see, the create table artist, and it's gonna create all of those tables with the constraints that we defined inside this model. So let's have a look at what is happening in here. By the way, these are generated files that you should never actually change anything. I'm going to just illustrate the contents so that you can understand better the internal workings of Entity Framework. So the artist table has a primary key artist and points to this through the artist ID column. Okay, which is actually called primary key artist. Genre has two columns, genre ID and name, and the primary key for genre points to the genre ID, so this column here. The media type works exactly the same, and the media type, the primary key is the media type ID. Then we have the playlist table, which actually what it does, it says I have a primary key playlist and points to this playlist ID. Then we have album table, and the album table has album ID, title, and artist ID. The primary key is album ID, and then we have the first foreign key. So it's saying that the foreign key album artist ID, it points to through the album through the artist ID column. It points to the artist table and especially to the artist ID column in the artist table. Then we have the track table. Here we have a bunch of columns, okay, which are essentially just text columns. But what we are actually interested to is that this one has a number of constraints with the primary key and foreign keys. So the first foreign key is the album ID. So the column album ID, so this column here, which is used here, x.albumid refers to this block. It refers to the album and then to the album ID. And here we can see this sounding very important, which is on delete, what is going to happen is a cascade delete. What does it mean? When you have a relational database and one entity is set to null somewhere, then every reference to that entity is going to be deleted. The reason for this is that imagine you have a track or an album or something that is going to be deleted. It doesn't make any more sense to have this album to be set to null, okay, or to have an ID that doesn't exist anymore. You're gonna try to find something with an ID, but that ID doesn't exist anymore, doesn't belong to it anymore. So when a track or an album is removed, then the references to this one are also removed. That's what is a cascade delete. The same goes for genre and for media type. Then we have the playlist track, and the playlist track is a joined table with a playlist ID and a track ID. And again, this one points to the playlist table and to the track table through the playlist ID and the track ID table. And finally, we have some create index methods. Those create index methods, what they do, they simply say inside the database you have those indexes, and those indexes are in the artist ID is gonna be in the table album is the artist ID column, and so on and so forth. In the second file, we are looking at how those entity models are created, what they look like, and this is all auto-generated. So now at this point, I haven't modified my database at this point. So what I'm gonna do, I'm going to open the terminal and I'm going to run database update. What this is going to do, because I need to be inside data layer, this is going to create our database. So I go inside API, I have a database, and I can actually open it with Command-Shift-P. Open database. It's going to recognize that I have this database in here. Let's have a look at let's have a look at what it looks like. As you can see, we have an EF migration history. The EF migration history is a table that contains all the migrations that have been applied to the database. Every time you're gonna run EF migrate database update, this table is going to be looked, and then this migration ID is exactly the name of the file that has been created in the data layer migration. So as you can see, it's exact same name, and this says which version of the tool has performed the migration. So then going back to here, we have the album table. As you can see, we have an album ID, a title, and an artist ID. And we can also see that those have different icons. So this one, you can tell it's a primary key because it's this key sign. This one is a property from the item itself. And this one, which has this empty diamond, is a foreign key. And you can see this everywhere else. As you can see this with the type and... Anyway, so this one, it's our migration created. And the last bit of today, what I want to do